Hey everyone, my name is Sachin Chokse. I'm an engineering manager in the Microsoft Azure machine learning team, and it's part of the larger advanced analytics suite of applications that we have. How's everyone feeling? Still a little comatose from lunch, maybe? All right. That's always a delicate balance if you're speaking right after lunch. You don't know how much your audience has eaten, and you don't know how much you should eat. So I try to eat just the right amount. Guys in the front rows, you are in the splash zone, so just heads up. So feel free to come on up. I'll try to keep it contained. But again, my name is Sachin, and I'm an engineering manager in the advanced analytics team, usually actually in Azure machine learning. So when we talk about advanced, oh, so are we on now? I see. My slides aren't going forward. Okay. How do I advance?
Just say next, and I'll change that out of your laptop. But say next if it doesn't work.
Okay. All right. So when you think about advanced analytics, I'm kind of short, so I can't see these. When you think about advanced analytics, people ask, like, is it essentially business intelligence? Are you just guys rebranding business intelligence and trying to pull a fast one? And the answer is no, right? Obviously, when you, usually BI, traditionally, it means you're looking at something that's already happened. You're looking at it in a dashboard. You've got a bunch of humans looking at data as it's happening real time, and they're trying to make some decisions on top of it, right? Which is fine, which works great, but there's one really key piece here. Humans don't scale. Now, if you've got machines who can predict what's going to happen, because that's essentially what the human's doing when he's looking at real-time data and making decisions. He's predicting what will happen, and he's doing something about it. Now, if you can have machines that can do that prediction for you, suddenly your decision capacity has scaled infinitely, right? You've got a lot more machines, and they're a lot more capable than humans, as much as it pains me to say that. So now you're in the realm of predictive analytics, and I'm probably preaching to the choir here, so I'll quickly advance over this. But once you've gone over predictive analytics, once you know what the machine, what's going to happen, you can also tell the machine, well, this is what you do about it, right? Here's what your algorithm should do. You know that customer is going to churn. You want that customer to receive a marketing email or a coupon so that they can stick to your platform. So that's now you're in the prescriptive analytics realm of things. Next, please. So what's new here, right? Why are we talking about this now? Over the last 4 or 5 years, with the advance of cloud computing, everything in our business has changed, right? It's an amazing time to be in this industry, where between 2011 and 2016, we have a 5 times increase in cloud capacity. The amount of data that is being generated in the world is growing exponentially, right? 90% of all the data in the world today has been created in the last 2 years. And this is before IoT has even hit us, right? You're talking about PCs generating data, then we went into devices, and you have billions of devices generating data. And then today in the keynote, we talked about trillions of IoT sensors are also going to be generating this data, right? So the size, velocity, all of that, how do you actually account for all of that? And all that data has value. Earlier in the keynote, we heard about, well, previously companies used to throw away their logs, and now you have companies trying to mine those logs because they have a ton of valuable information in them. You have customers who are talking to you all the time via social media. They're tweeting about you, they're Facebooking about you, they're writing articles, or they're posting blogs on LinkedIn, right? There's over 1 billion people talking on social media. What are you doing about it? And how can you actually pay attention to that and react to it? That's the prescriptive part. And of course, there's a ton of new data scientists that have the capability of leveraging that data. Every university out there today has a data science specific program, and new ones are cropping up before you know it, right? So sooner than you can count, new data science talent is emerging. So there are people out there who can help make value, who can help derive value from this data. Next. So when we talk about the advanced analytics landscape, Machine learning isn't something new, and machine learning is part of advanced analytics, right? It's not new. It's been around as a field, as a science for over 20, 30 years, right? But traditionally, when you tried to use machine learning and advanced analytics, you had huge setup costs. You had to go buy your own servers, compute, storage, everything was expensive. And when data existed in different companies, the data existed in their own silos. The finance team had their own data, the marketing team had their own data, engineering had their own data, different business units ran their own data, and they did their own analysis, and they all worked on it in a very siloed manner. You had disconnected tools. You have data scientists who use R and Python, and you have the engineering team who uses Java and C# and all their other tools that they're using for DevOps, right? And there's a tremendous amount of deployment complexity. Your data scientist builds a model, it's in R, it's in Python, and he goes over to his engineer and says, hey, I'd love to deploy this. I wrote this new algorithm. It's, I've run the numbers. It's going to save us about $10 million, compared to last year. And the engineer says, great, come back in a month. I've got DevOps to worry about. That model that you just developed, that's, so valuable to the company, it's going to take a while because the language essentially is different. So there's a tremendous amount of complexity in actually deploying your models into the cloud. And this is where the differentiation occurs, right? Within the advanced analytics platform that Microsoft offers. And I know these are a bunch of marketing slides. I'm an engineer. I got to go through this. So we'll get through this together, you and me. So this is where the differentiation occurs in the advanced analytics landscape that Microsoft has, right? If you're a data scientist, you can use the tools the way you like them. If you've got no coding ability at all, you can still use Azure Machine Learning, which is a team I work in. You can still use that tool set, and it's a drag and drop environment. You can drag and drop your algorithms. And these are the same algorithms that are being used in Xbox and Bing and Cortana. And you can essentially drag and drop them and use them for your applications, not a single line of code. Now, if you are an R developer or a Python developer, you can bring those too. You have native support for R and Python. You can, again, drag and drop an R module and say, I'm going to just put my code in here. And now suddenly you have your R module and your Python code running in the cloud. So all skill levels, business-tested algorithms, native support for R and Python. You've built your model, everything's hunky-dory, you want to deploy it. It's literally one click. One click, and the model that you built, either through drag and drop, or with your own code, or a mixture of the two, and the example I'll show you has actually a mixture. You can deploy it within minutes to the cloud. And then, if you have truly developed some unique IP, you can actually make money off of it, right? Let's say you've written the next great image algorithm or image recognition algorithm, something that picks out entities and what's inside an image. You can take that and deploy it to the Azure Marketplace, and all of a sudden you have a global set of customers who can leverage your application and leverage your model and consume it as a web service, because your model, when it's deployed, is essentially an API. And you're essentially consuming that in that application. If you don't have your own data scientists, there's a ton of good APIs already in the marketplace. Let's say you're trying to do churn prediction. There's something that is already developed and deployed in the marketplace. Pay-per-click, pretty much. Next slide. So what does an advanced analytics application really look like, right? Here's a generic architecture diagram that we came up with. So if you're thinking about churn prediction, right, you've got people who are looking at. We'll start from the right-hand side of the slide, because that's where the business happened, right? You've got people who are looking at dashboards, and there are processes that are running that are trying to figure out who's my customer who's going to churn, and what should I do about it, right? Once you've identified that, right, how are you going to get to that dashboard? So you've got a bunch of data that's sitting in a cloud service. Let's say it's Facebook data or social data, Twitter data, and you're consuming that. Or you've got a bunch of on-premise data from your marketing team, and that's sitting in a local desktop file, right? So that data essentially gets moved into the cloud through cloud storage. This would be Azure storage. You'd set up automated data pipelines, stuff like Azure Data Factory, Azure Stream Analytics, move that data into the cloud, You've got Machine Learning Studio, which you can actually use to run models against that data, and then you can deploy that model as an API. So the model is now running as a web service, and then if it's truly unique IP, you can even monetize this. You don't have to. You can use that API internally within your own application. Or if you feel like it's truly unique, you can monetize this by deploying it to the marketplace and charging people for use. And that entire payments infrastructure is obviously taken care of by Azure. And you can consume it in your own applications through those dashboards and processes, and then kick off that marketing email that we spoke about earlier. So how do you actually piece together all these different pieces? So we're referring to this as the advanced analytics process. This is something that my team's actually been working on. So the goal of ADAPT, Advanced Analytics Process in Tech, is to set up mechanisms, or establish mechanisms to conduct data science activities end-to-end in the cloud or on premises, whatever the case might be, friction-free, right? So what does that mean? You're going to set up your data science environments in the cloud. You're going to move your data from on-premise to the cloud. So this is your marketing team's data. Or you're going to consume data from existing cloud sources. So you can set up your ADF pipelines or stream analytics. You're going to figure out how do you explore and understand your data. And so this is something that your data scientist is going to do. And then you're going to build a model with Azure Machine Learning. And once your model is built, you've tested it, you think that it's the best model that you can do, you're going to deploy that model. And then you can obviously iterate over it seamlessly, because the deployment complexity is so low. It's one click and you're deployed, right? And then once the model is deployed, you're actually consuming it in an application, right? So this sounds all very theoretical, right? Because that's what ADAPT right now is. It's a very theoretical framework. But what we've also done is publish end-to-end walkthroughs with real data sets, and that's what I'm going to show off today. Next slide. So let's talk about the hands-on walkthrough. So you could just cycle through this. So what I'm going to show today is how do you set up your cloud environment. Actually, we'll skip over some of that stuff because I've already done that. Setting up your cloud environment, loading your data, exploring your data, creating new features if you need to, downsampling that data for use in machine learning, building your model with Azure Machine Learning, deploying that model, and consuming it, right? Repetition is key. I know you're all kind of sleepy, so I'm trying to make sure that this gets through. Next. Right, so today we're going to demo this specific process with a 1 terabyte data set. So we're not going to set up our cloud environment or load the data, because that would take a while, and if you're not sleepy, that'll be not helpful already. You'll get there. So we're going to talk about actually hitting a terabyte data set that's already been loaded. The environment has already been set up. In this case, the environment is, I've got an Azure VM running IPython notebook, which I'm going to use to interact with the data. And I'm going to, the data is loaded in a 32-node Hadoop cluster. It's on HDFS. And I'm going to take that data, I'm going to play with it in IPNB. I'm going to downsample it and then process it in Azure Machine Learning. I'm going to show you a cool technique called learning with counts. And then we're going to deploy the model. So next slide. So let's talk more about the 1 terabyte data set. So this is an open data set. It was released by Criteo. Criteo is a display advertising company. This is the land of Yahoo, so you guys know very well what that means. Criteo is based in Paris, France. And they work with internet retailers to serve personalized online ads, right? Banner ads, essentially. And they have a cost per click business model. The data set we're going to talk about, which Criteo released, and it's hosted on Azure, as well as a bunch of other places. It contains click feedback for millions of ads. It's 24 days of ad-click data. So 24 days of data is over a terabyte, and this is a curated set to some extent. So it's 1.1 terabyte uncompressed. It has 4.3 billion rows, and has 40 columns. All the columns are hashed, so you can't actually figure out what they mean, but that's not going to stop us from actually building our model. So there is one label column within there, which is the very first column, column 1, and that essentially contains a 0 or a 1, which means 0 means the ad is not clicked, and 1 means the ad was clicked. It has 13 numeric columns and 26 categorical columns. And those 26 categorical columns are important, so we'll talk about how, the more categorical columns you had, the harder it becomes to train these models. So if you want to go ahead and play with the data yourself, it's all on the previous slide. I had a link. It's at the very bottom right, labs.criteo.com. You can download it, and there's more information about the data set as well. All right, so there will be a quiz, so pay attention. So day 0 to 20, so if 21 days that Criteo is calling as historic data. Day 21 is training data. We're going to use both day 0 to 20 and day 21. But Criteo wants us to learn from that day 21. It's 190 million rows, 45 gigs uncompressed. Now the whole data set, remember, is 1.1 terabytes, right? So you've got 190 million rows, 45 gigs uncompressed. Day 22 and 23 are both considered test data. One of those days is a holiday, the other isn't. Criteo hasn't told us which one's which. Right? So we'll use day 22 as our test data set. Again, it's 190 million rows roughly and 45 gigs uncompressed. That's the amount of data in each day. And right below there is a sample of what that data set looks like. Next slide, please. So what do you think you guys are going to predict? Yep. Will an ad receive a click, right? Very simple. Something that is very commonly done in a number of places. Next slide. So how many of these ads actually have clicks, right? What's the distribution of our labels in this data set? Go ahead. Okay, so ads with click, we have 3.3% positive cases. So 3.3% of all those 4.3 billion rows received a click, and 96%, almost 97% received no clicks at all. So we're going to downsample the test and the train data set. Remember, this was the test data set. The train data set is from day 21, and the test data set is day 22 and 23. We're going to only work with day 21 and 22. We're going to take a 1% sample from this data set. So the training data set from that day 21 is essentially down to 551 megabytes, 5.76 million rows. And the test data set is 543 megabytes and 5.69 million rows, right? At this point, you guys are saying I'm going to cheat because I'm essentially downsampling. We'll get to that later, right? So as you can see in the test data set and the train data set, in the train data set, 3.3% ads have clicks. Again, in the downsample, the distribution is exactly the same. So you know you're roughly at have a very similar data set. It's a fairly representative sample. But if you've done machine learning and you've got a very underrepresented suppressed class, you know that can be hard to train a model in those scenarios, right? How many data scientists do we have here? How many aspiring data scientists do we have? I'm an engineer. I only masquerade as someone who knows what they're talking about in my team. But so what we're going to do actually is we're going to take those imbalanced classes and downsample our positive class so that we actually have in the final training model, we have about an equal representation in the positive and negative classes. So now you're saying, okay, you've got day 21, you know, or day 22, which was your test data and your train data, and you got a couple of days of test data. But what about the 21 days before that? Where did that go? What are you going to do about it? So we're going to talk about this interesting technique called learning with counts. Anyone familiar with this? How do you learn with counts? It's actually not a very well-known or romanticized technique, let's put it that way. It is something that's immensely useful. It is done, but it doesn't have a great name. So our team called it Distributed Robust Algorithm for Count-Based Learning. It's a bit of a mouthful, so we called it Dracula. And anybody who knows, who's watched Sesame, how many people watched Sesame Street growing up? What's his character's name? Count. He's got a full name. Sorry? No, his name is not Count Dracula. I hope Sesame Street is not going to sue me because I'm using his image. But his name is Count Von Count. So can you tell he likes to count in his typical accent? You know, 1 a penny, 2 a penny. That was my very poor implementation of Count Dracula. But my daughter watches it every morning. That's what we wake up to. But so learning with counts, it's a neat technique that's built in Azure ML. It's got native support to build conditional counts on high-dimensional categorical variables. What it does is it takes that 21 days of data that we're talking about and essentially says, okay, you've got a lot of categorical features in those 26 columns, right? I said there would be a quiz. How many categorical columns do we have? 26, exactly. Someone's paying attention. You did not have lunch, did you? Took a picture, all right. All right, cheating is allowed. So yeah, so you've got 26 columns with categorical data in there. And you're essentially going to take all those categorical columns, and they have certain hash values. And you're going to compress all of them by counting how many times each hash value occurs for a specific class in your label. In this case, we have a binary label. It's a 0 or a 1. So you're going to say, OK, column 16, for example, which is one of those categorical columns, has 40,000 unique values in there. And for class 0, it occurs A times. And for class 1, those values occur B times, right? So now essentially you've taken those 4.3 billion rows, it was 4.3 billion rows, and you've compressed that into 80,000, right? So you're essentially counting how many times categorical variable occurs. And that's a great way to teach your model what to expect in the rest of the data. So this is a commonly used use case in advertising and fraud scenarios, because obviously the number of clicks or the amount of fraud chargebacks, those are they're very low in number, right? So we used it for days 0 to 20, so 21 days of historical data. We essentially built count tables over it, and I'm going to show you how to do that. Learning with counts, if you're interested in this more, there's an amazing blog post that Misha Milenko, who's on our team, he's a principal researcher, came over from Microsoft Research. He's written this really cool blog post on how to use that in Azure Machine Learning, so aka.ms/learning with counts. All right, so let's go back to our demo. Just to recap, we're going to explore that data, that 1.1 terabyte data, engineer features, sample some of that data, build a model in Azure Machine Learning with it, and then we're going to see how to deploy that model and consume it. Now, if you remember the name of this talk, it said doing this in a couple of hours. Would you like to be here for a couple of hours? Sure, OK. The people in the back said that at minute 40, you'll hear a rifle clock, and then I'd be ceremoniously or unceremoniously booted out. So I don't think I can be here that long. So we're going to do this recipe style, right? I'm going to show you certain sections, and then I'm going to show you what the result of that action is in a different section. All right. All right. What we've done is we've loaded that data in a Hadoop cluster. It's an HDFS, and it's an external table. I have created, using that process I described earlier, adapt. I set up a virtual machine. When I set up that virtual machine, it came customized with IPython notebook. I have this IPython notebook that's, by the way, it's checked in GitHub, so you can go play with it. I'll show you how to do everything that I'm demoing here yourself. We have an article out there already. It is an entire walkthrough end-to-end that goes from everything that I've skipped as well, setting up your environments, loading the data, and then setting up these VMs and playing around with them in IPython notebook. So so this is a VM that was already set up. It has IPython notebook on it. I'm going to skip over some of this. This is essentially talking about the same stuff, getting the data from the source, describing the data set. We are going to work with that training data set here. So that's day 21. So let me go ahead and start working through this. All I'm doing here is importing some packages, establishing a connector to my Hadoop cluster. Let me see what the contents of the default database. OK, thank God the cluster is up. You know how the demo gods work. So I am going to create a new user here and essentially use that to create a new database. So what this is doing is essentially creating an internal table that holds that training data as well as that test data. Test data is looking at day 22. Training data is looking at day 21. Click that. There's my cursor, so it did complete. Let's go look at the tables in the database. So it has day 22 and train. Those are the two tables I just created, and they're mapped over to that main data set. Let me pull a few records from this. So those are the top 5 rows for the training data set. This is the next 5 rows from my test data set. So what you'll notice here is, in order to keep this interactive, I'm only running a 0.05% sample, but I'm going to kick this off. And there we go. That shows me my kernel is busy. But essentially what I'm doing here is pull something from the training data set and where it, for a 5% sample. And this usually takes about 4 to 5 minutes. And I'm going to stop and ask if anybody has any questions at this point. Nope. OK. Yep. So this entire walkthrough, I have a slide at the very end with a set of links. And you can take a picture of that. It's essentially, if I remember correctly, I created it this morning, aka.ms. I don't remember it very correctly. So the link, there's a slide at the very end that has a walkthrough with everything in it. And that's essentially a guide that shows you how to step through the whole process, as well as a link to this. This is checked into GitHub. Don't bother taking this down. I'll be destroyed pretty quickly. OK, this is still working. So while it's still busy, let me talk about what I'm going to do next, right? We're going to talk about the label distribution. So we're going to plot the different labels as soon as my data frame is loaded up. I'm going to plot the different labels in the data set, and we're going to see that imbalance classes. And then we're going to examine the the histograms of numeric variables. So I'm going to look at column 2 and column 3, and I'm going to bin them and try to figure out, what's the distribution of data. So what I'm essentially doing here is trying to get a feel for the data, right? This is what a data scientist will do. He'll load that data, and then he'll try to interact with it in some manner. He's going to try and figure out, what are all the features, what's the distribution, what looks interesting, what doesn't. In this case, Criteo hasn't given us any information, right? They have totally hashed the data set, and it's scrubbed. So your column names aren't really descriptive. So this column 1 to column 40, that's pretty much all you have. So you're not going to get a lot doing this, but it's still a good way to understand how your data is distributed. So we're going to examine those histograms. So you can obviously take this and extend it for all the columns. I'm going to only show a couple. And then we're going to actually do the downsampling and the training of those data sets. And I'm going to use a 1% sample here because I'm going to store that off. And then I'm going to read that in Azure Machine Learning. So I am trying to kill time. Any other questions? Go to the, you want to see the last slide? All right. Let me show you. It's called Criteo Hadoop Walkthrough. Sorry? If I push this full screen, he's running it off his laptop. Can you? Yeah. I didn't do anything. No, the last slide. Oh, OK. Well, could you switch back to mine? Is that visible? All right. Let's switch back and see. Oh, look, it finished. 228 seconds. So yeah, I was about right, about 4 to 5 minutes. So you've got your data set now. You've got a 0.05% sample of that data. Let's see what that data looks like. Let's just figure out how many rows and columns. So I've got about 96,000 rows, 40 columns in this one. Like I said, it's a 0.05% sample. And let's look at some simple data summaries. So these are the kind of things that a data scientist would do, right? You'd look at all the different columns and the means and standard deviations to get a feel for everything. Let's look at the 70th percentile for some of the quantiles, and that's for each column and for each of the numeric columns and what the quantiles are, the 70th percentile. Let's import matplotlib. And now let's look at that label distribution, right? Zeros and ones. So these are the number of ads that had no clicks. And these are the number of ads that had clicks. So like I said, when we move this into Azure Machine Learning, we will actually fix this, and we'll have a 50-50 distribution of these. So you've got some, this is column 2, and these are all the distributions within, based on these intervals. Same thing for column 3, and you can do this for the entire data set and for all the columns. But what I'm trying to do is essentially give you a feel for how this works. So I'm not going to go through and creating this sample, but let's see what we have at this point. So you should have a train at 1% and a test 1%. So now once you're in Azure Machine Learning, and I know this looks horrible, thanks to this resolution that I've been forced to use, you can actually drop in a reader module, and you can connect it to a Hadoop cluster. So this is Azure Machine Learning, by the way, for those who haven't seen it. You can drag and drop different pieces in here. So here I'm basically just getting all the data from the Criteo data set, from the 1%. And you can connect to that using a Hive query, and you can pull that in. Pulling this data in will take a little bit of time. So here's 192,000 rows. It's a 1% sample, not the 0.05%. So 1.92 million rows, 40 columns. So I'm going to switch over to the actual experiment, right? So this is the experiment that me and my team built for this case. So this is that training data set. I essentially, if you go back here and you right-click, and so you can save it as a data set. So in order to speed things along, I saved it as my training data set and my test data set. I could have done this in one experiment, but just doing it fast, cooking show style. I'm going to clean some data. You can obviously see that that data set has a bunch of missing values. Let's look at it. Look at this. There's a bunch of things in there. This is, again, my label data set. So it has that skewed representation of the classes. This is where I was talking about you can run your native R code. So I'm going to execute my R script, and it's right here. Okay. Somehow it's compressing it, so I can't really see it at this resolution. But let's see what the output of the R script is in terms of a data set. So now you can see that I've actually got a pretty balanced representation of my clicks and no clicks. I'm going to skip over some of the learning with counts. It's, all that information is there in the slides. Let me zoom out a little bit so you guys can see this. Well, maybe you can see it, but I can't. So I have dragged and dropped a boosted decision tree. Here's a 2-class boosted decision tree that I've used in this case. And I've dragged and dropped that, and I have trained my model, and here's my evaluation from that model. So ROC is So my AUC is 0.759, and I can obviously tweak that threshold to get different false positives and different false negatives. So once you've done this, and now I'm trying to speed along, you can actually say, prepare a web service, right? This is that one-click deployment I was talking about. You can prepare a web service, and here's that experiment in a web service, and it's essentially running in the cloud. And you can say, publish this web service, and that's what pushes it to the cloud. And here's the API page. Like I said, I'm skipping through some of this stuff, but once you've actually published your web service, this is the API page you get, and you can run through request response. You can do a batch execution or a request response, whatever way you feel appropriate. And if you choose request response, you also get sample code on how to call the service in C#, Python, and R. And so now you've gone from a terabyte of data to a model running in the cloud. I showed it to you within 40 minutes or 25 minutes, really. But if you'd actually gone through it, it'll take you a couple of hours. But if you need instructions, you have the slide up above. Let me show you what those are, what it is again. And if you have any questions, I'll be outside. Thanks, everyone. Again, my name is Sachin Chokse, and I'm from Microsoft, from the Azure Machine Learning team.